In the last video, we have learned the mealy model, and we also learned how to write the state synthesis chart for this mealy model. Now in a mealy model, this is a representation. Suppose there are states 0, 0 to 0, 1, and you will be representing when x equal to 0, output is 0, or when x equal to 1, output is 1, like that you will be representing. This is another state. So this is input and this is output, and these are states. So the conclusion in the mealy machine is that the output depends on input, and present state. This is the conclusion of mealy model. Now the same digital problem can be modeled using another method called the Moore model. So today in this video I will be explaining how to write the synthesis chart for the mealy model, Moore model. So what is Moore model? Here also there are different states like 0, 0. Assume that this is another state 0, 1. This is 1, 0, and this is 1, 1. Now in Moore model, the representation is if x equal to 0, we will be representing like this. Will x equal to 0, it is going to another state, but we won't be representing the output here. We will be representing the output at the state itself. We are saying that, for example, we are saying that the output is 0 here, and x equal to 1, it is going to another state, and we will not be representing the output here. Output is not at all dependent on the input. We will represent the output here. Assume that output is 1 here. Now one more case I am writing. At this state 1, 0, at this state 1, 0, if x equal to 0, it goes to state 0, 0, this state 0, 0, and you are representing the output here in its state. You are saying that we are saying the output is 1 here. At the same time, if x equal to 1, we are saying that it goes to next state where the output is defined as 1. So here the conclusion is output depends only on states. It is independent of input. Whereas in the case of mealy model, this is the way we represent output. This is output. Output depends on present input, present state, etc. So this is the main difference between mealy and Moore model. In the case of Moore machine, output depends only on the states. It is independent of the input. We will be representing the output on the state itself. This is the normal way to represent. Now we will learn how to write the state synthesis chart for a Moore model. This is also very simple. First I am going to draw a Moore state diagram. Assume that there are 4 states 0, 0, 0, 1, 1, 0 and 1, 1. I know the first case, when x equal to 0, assume that it goes to this state where the output is defined as 0. X equal to 1, it goes to state 1, 1 where the output is defined as 1. Now at this state, if x equal to 0, it goes to this state where the output is defined as 1. If x equal to 0, it goes to this state where the output is defined as 0. Similarly, you can write the expression for this state 1, 0 and this 1, 1 also. Since there are some space limitations, I am not going to do it here. You can do. Now we write the state synthesis chart. So the procedure is first to identify the total number of flip-flops required. So since there are 4 states 0, 0, 0, 1, 1, 0 and 1, 1, it's a 2-bit representation. So you need maximum of 2 flip-flops to get the 4 state. So you selected 2 flip-flops. So you can use JK flip-flops or a T flip-flop. It's not specified. So I'm using 2 JK flip-flops. So when you draw JK flip-flops, it will be like J1 K1, output is Q1, J2 K2, output is Q2. So ultimate aim is you need to find out what is J1 K1, J2 K2, etc. and implement. So we'll be using the same technique. First we will write what are the present input, that is what is the status of q1 and q2. Okay, present state, this is present state. Okay, now we write the present input, what are the values for x. X can be 0 or x can be 1 also. And we will write what is the next state, q1 star and q2 star. And we also write the output is y. And then we find out j1 k1 j2 k2, similar to the mealy model. Now we'll start with the first case. If the present state, I am starting with this case 0 0, so present state is 0 0. In this state x can take two values, x can be 0 also, x can be 1 also for the same state 0 0. So you write when 0 0 is the state, x equal to 0, what is the next state? So x equal to 0, it goes to the next state is 0 1. And in that case, what is the output? Output is defined here. Here is the output is defined for that state is 0. Similarly, x equal to 1, it goes to state 1 1. And what is the output at 1 1? At 1 1 the output is defined as 1, so you have to write that 1 here. Now based on this q1 and q1 star, you find out what is j1 and k1 using the excitation table. Just like we did for the synchronous counter, you find out what is this j1 k1. Similarly, by using q2 and q2 star, you find out what is j2 and k2. Now you write the next state 0 1. 0 1 also having two combination for x, 0 and 1. So you write the for 0 1. Similarly, you write for 1 0. 1 0 two combinations. Similarly, you write for 1 1 also for two combination. And after that, simplify using k-map. So how will you simplify using k-map? Your inputs are q2, q1 and ex. So you have to draw a 3 variable k-map for finding every variables. So first you are going to find out what is the value of y. For that you will be taking q2, q1, x. You have to find the value of y. So these are the input variables. And based on using the column of y here, you have to fill the values, simplify using k-map and obtain the value for y. Similarly, you find out what is j1, k1, j2, k2, etc. Once you get the value for all these, implement using a k-map. So this is the states in the sys chart of a Moore model. Now I will give you one practice question, and you have to do this and submit by, I will inform you the date you have to submit. After watching all these videos, you have to submit that. The question is, design a pattern detector which will detect the pattern 0 1 1 in a number stream, which means the numbers are coming like 1 0 0 1 1 1 1 1 etc. Assume that the numbers are coming. Whenever the pattern 0 1 1 comes, in that pattern you have to recognize. So first you do the example with a mealy model, then you try with the Moore model. Implement, you have to draw the state diagram in a mealy machine, synthesis chart and simplify. Similarly, the same problem you do with a Moore model, then you will understand what is the meaning of state machine. You will understand what is the meaning of input, what is output, what is mean by state, etc. So solve this example and submit that. I will inform the date you have to submit.